Oh, from my end?
Okay.
I'm not sure. We're good now. Okay. I should start by thanking the British Antarctic Survey for being such gracious hosts. All of you are the beneficiaries of brand new technology. So they've recently redone this room. So we have some top spec technology to be working with for Polar Data Forum 5. So just for those of you who are here, those of you online, you probably don't have to worry about this. But fire alarms are tested on Wednesdays at 12 o'clock and 12:05, so probably not today. But if there is any incident or emergency, please contact reception. Toilets can be on the ground floor of the Aurora, ladies to the left and gents to the right, just across from the theater. And there is a well-being room on the ground floor for anyone needing a quiet moment in a private room. And if you need access, please feel free to get in touch with us. So I'm guessing that the reason that most of you are here in this Polar Vessel Data Workshop is that in some degree, you're interested in polar data or you are interested in marine and vessel data and are wondering how to handle it. I'm going to explicitly avoid wasting time by going around the room and having everybody introduce themselves. But I will say that if discussion time comes, please do introduce yourself and your program. So our first session is really about trying to get an understanding of the polar vessel data landscape. By way of introduction, I'm Jonathan Kuhl. So I am with the Australian Antarctic Division. I am the AADC, the Australian Antarctic Data Center Manager. And so in addition to that, I'm also the chair of SCADM, so the Standing Committee on Antarctic Data Management. But one of the things in the Australian Antarctic Division, we have a new icebreaker, which is the RSV Nuina. It's just come into effect or into commissioning. And we've had to develop new data pipelines in order to collect the information and get it back to our data repository. And so we have several hundred sensors on the vessel. All of it ends up being collected on the servers. There is going to be a dedicated discussion relating to data transfer, but we have it on Snowball devices. And that gets offloaded to our data center where we undergo checks. But we do have those dedicated data officers aboard. In terms of other ships on the horizon, I did have Masaki share some slides with me from the Japanese program. So I'm just going to bring those up now. Let me just end this slideshow. And I will now share these slides. So that's now come up. So this is a schematic of the new Japanese vessel that's going to be developed principally by JAMSTEC. In 2021, the construction began, and they're trying to use it to, as many of us are, detect various issues and environmental changes. In terms of their specifications, these are them here. Length of 128 meters, 13,000 tons. It does have ice-breaking capacity as well. It is diesel fuel with a variable pitch propeller, and the expected completion date is going to be in November 2026. In terms of construction, this is the timeline here. And there is a website that provides more additional information. Masaki, is there anything that you'd like to add sort of about the development of the Japanese icebreaker?
I'm not directly involved in this new vessel, but Professor Yamaguchi, he is now the project professor of NIPR.
Sorry.
I'm not involved in, directly to the new vessel, but Professor Yamaguchi, he is now in the project professor of NIPR. Please contact him directly for more detail, and also the other Japanese colleagues. And in my understanding, the first few years or more than 10 years, mainly aiming to the utility as the Arctic Ocean operation. But in far future, probably the usage for the Antarctic operation, so bimodal operation in any future.
Thank you.
That is not official.
Not official information, but at least, again, this is meant to be a discussion among colleagues, just to share information. Yes, this is relatively informal. Alex, would you like to provide an update on what's been going on with the Sir David Attenborough?
Yeah, sure. I'll throw it.
Oh. Sorry, Petra.
That was close. So, I mean, I'll give a bit more information in my talk on Thursday morning. But the Sir David Attenborough started trials in late 2020, and it's been doing a variety of ice trials and equipment trials throughout. It has been down to the Antarctic. It's done a couple of seasons south now, and it will be doing its first funded science. We've had a polar science trial, so a demonstration cruise earlier this year. It'll be doing its first funded science, which Petra will be supporting in December this year. Throughout that time, from 2021, early 2021 onwards, although it was difficult to start with because of the pandemic, we've been commissioning. So that is the royal we, so IT engineers, lab managers, data managers, been commissioning the various systems and sensors on the vessel, and we're still getting to the kind of the last element, and that may well actually go on for a couple of years more before you could say business as usual. As you know, I mean, things always evolve, but you know, the initial commissioning phase. So I mean, I'll talk more about that on Thursday, but that's where we are in the ship schedule.
So please stay tuned for the Thursday sessions as well. So I'll avoid. There we go. That was me getting hung up. So do we have any other representatives in the room that have icebreakers or ships or capabilities that they would like to talk about? I know that Germany has a new vessel coming up, but I'm not sure that we have any representatives. Frank, any knowledge from the US program? Well, fair to say no.
I don't know. I'm not like totally involved in this, but they're planning a new ship, but that's not going to get online before 2030 if it gets built. I mean, the design phase, and Congress has to approve. And we see what Congress will be able to approve.
And the current vessels are working as intended.
Yeah, I think you have two vessels. The bigger one, the Palmer, is I think that will be commissioned until like 2030. The smaller vessel, the Gould, might get out. I think the lease ends earlier, and they might not renew it. That's a whole big discussion. Instead of only having one vessel down there.
Yep.
But like the main vessel at the moment is going to be the Nathaniel Palmer, still for the next couple of years.
Great, thank you.
We've got a hand raised online as well, Brendan.
All right, yeah, please, Brendan, if you can unmute yourself, go ahead.
Sure, can you guys hear me?
Perfect.
Great. Hi, everyone. I'm Brendan. I'm with the STARK program. It's funded by the U.S. National Science Foundation to support science on the Coast Guard cutter Healy. So we are planning the midlife refit of the Coast Guard cutter, and NSF is committed to funding the next generation of sonars as well as update the instrumentation on that ship. So of the academic ships, Healy is the only one that can make it to the North Pole, and we did so last year, as well as transited from Alaska to Europe recently along the Russian margin, which was interesting to say the least. As a community that's interested in data, there's some interesting developments in the future regarding the next generation of polar icebreakers. The polar security cutters they're funded and they're being manufactured primarily with security in mind. There is another generation of ships that will be coming after that called the Arctic security cutters, and the size has yet to be determined, but the scope and the technical specifications have not yet been completed. So there is an opportunity for the academic community, nationally and internationally, to provide input on these vessels and recommendations for their capabilities to the U.S. Coast Guard in order to ensure that they are capable and contributing to the body of science that we would like to see, not just doing Arctic security missions. So I just want to put that out there. There is a UNOLS committee called AICC, which is the Arctic Icebreaker Coordinating Committee. If none of you or if any of you are familiar with that, I would encourage you to contact Lori Juranic with Oregon State University. And as she's the chair of AICC, she can provide more input on that and the future direction of U.S. Coast Guard or U.S. icebreaking capabilities. And this is independent of the NSF's Antarctic icebreaking vessel that is in development but not yet funded. So we try to collect data as much as possible on these U.S. Coast Guard icebreakers, and they are valuable platforms for Arctic and Antarctic research. We hope to see them develop further in the future. Over.
Great. Thank you very much, Brendan. That's exactly the sort of information that it's useful to hear. Is it possible to shift the camera to the room, or do
So everyone sees the full room. The reason you can see that screen is because it's from your.
Oh, I see.
If you want to shift that, you can shift it to point at you, or you can stand in front of it like that.
We'll kind of shift it over that way. All right. Not sure that that helps. Anne.
Yeah, I can add as well. So I'm Anne Treasure from South African Polar Research Infrastructure. And in South Africa, we've got the SA Gallus 2 as well. She's about, I think, 10 years old now, 10, 11 years old. So from the SAPRI side, we're certainly looking into ways of improving the data streams, the workflows. So this workshop's going to be very useful. That's about
it. You avoided the cube. Yeah. Schmidt Ocean Institute.
Hi, everyone. I'm Corinne Basson. I work for Schmidt Ocean Institute, which is a nonprofit foundation that now makes our new research vessel, RV Falkor 2, available to scientists for free. So that started, the new ship came on board this last year. So we've done all new data systems and working to improve them. It is not an icebreaker, but it will be polar rated, and we're hoping to be in Antarctic waters within about a year.
Fantastic. Thank you very much. Does anybody else have anything that they'd like to add? Susanna.
Hi, hello. I am Susana Diez. I work in the Marine Technology Unit of the Spanish Research Council. I'm not directly involved, but we have a new vessel. It's not an icebreaker, but it will be global and polar, and it's the Odon de Buen. And I think it will be fully operational during 2025.
Fantastic. Thank you very much.
My name is Taco de Bruin. I'm with the Royal Netherlands Institute for Sea Research. And we're building a whole new research fleet. And the largest vessel will have some ice classification, but will mainly be used in the rest of the world ocean. It's being built right now in Spain and will be operational, hopefully, by the end of 2025.
Thank you.
Hi, I'm Shannon Christofferson. I am the Manager of Research Data Collections and Digital Services at the Arctic Institute of North America in Calgary, Canada. And I'm also the project coordinator for the Canadian Consortium for Arctic Data Interoperability. I have absolutely nothing to do with polar vessels, except that one of the members of the Canadian Consortium for Arctic Data Interoperability, or CCADI, is Amundsen Science, and they operate the Canadian icebreaker, the Amundsen. And it's been in operation for a while. If there's anybody online from Amundsen Science, though, they could explain a lot more about our research vessel.
Do we have anybody online from Amundsen? I'm guessing that we might not.
We've got a chat from Tess saying that add something on the Nuina.
Tess, are you able to speak?
Oh, hi. Hi, I'm Tess. I'm one of the aforementioned data officers Jonathan was mentioning. I don't have a red cube, but the closest thing I have to me red is these flowers. So I guess I'll just hold that. I was just saying, if you wanted me to add anything more on RSV Nuina, I'd be happy to, but you did, cover it. It was kind of
Yeah,
a question.
actually, if you could, because I spoke briefly about Nuina, but if you could just give a gentle introduction to some of the pipelines that we deal with and some of the daily life. I think my intent is to give people a sense of what our challenges are, and people will say, yes, I relate to that, or no, that's just you. So yeah, just a very brief introduction.
So RSV Nuina came online for us around 2021, and we did our first resupply voyage with her. We are still in commissioning, and I think everyone will understand the woes of commissioning, and they are quite challenging. And we are looking forward to doing a science project coming up at some point. Presently, the ship is just, as of probably right now, is finishing up the ice trials at the moment, and my colleague, the other data officer, Peter Shanks, is on board for that one. As onboard data officers, we collate, curate, provide access both shipside and shoreside to the data, and ensure that the data is safely stored. I think that's a bit brief. Over.
Yeah, we can get into the specific technologies later. So thank you, Tess. Does anybody else have anything that they would like to add from their programs, either what's going on now or aspirations in the future? Any additional? Oh, is that we have a gentleman online? No? Yes, hello.
Hello, I'm Michele
Hello.
Rebesco from Trieste, Italy. I'm a marine geologist. I have no specific experience on data handling. Our vessel is the Laura Bassi, which is going to Antarctica every year, and up to now once in the Arctic. You know the vessel because before was owned by the BAS, and we bought it in 2019, I think. And unfortunately, the colleagues of mine that are working with data from the vessel are not available for meetings in these days. So I will try to catch up something. I've been invited because there will be this new polar program, Polarin, that will start in March, and I am I'm leading the training work package, and within that there is a data stewardship task that I am supposed to co-lead, and that's all for now.
No, that's fantastic, and thank you very much. Any other comments from the room, from participants, or particular programs regarding ships or future plans? It's fair to say no. Oh, yeah. So I'll get you afterwards. But Niels.
Hello, I'm Niels van den Steen from Arbens, Belgium. Our new research vessel, the Belgica, is operational for, I think, almost a year now. We still have some issues from the data management side to get the data on shore. So that will be interesting to hear what the other solutions or your solutions are for that issue. Thank you.
Thank you. I will turn over to you in just a minute, but one thing, yes, Dave?
I'll just say for the people online, I think people need to hold the mic closer to their face when they're speaking, because I don't think people are coming through.
Okay.
The other point about that though is the ceiling mics are picking up our speech absolutely fine.
Okay, so
Possibly, other than the fun of throwing it. Possibly isn't. You can still throw it, but it's not necessary.
so don't pass it. I'd be worried about hitting Petra again.
Question, then you can throw it.
Yes. Like I said, I'll get to you in just a moment, but Nils speaking reminded me of one thing, which is we were speaking earlier. This is a polar vessel data forum. However, many of the things that we work on are not exclusive to the polar community. And so a lot of the tools, a lot of the technologies will be cross-applicable. And as Taco has pointed out to me, there are quite well-established polar vessel frameworks. So we shouldn't feel as though we need to rebuild all of this in isolation. And part of this is being able to talk about the broader community and plug into that broader community. So, you know, if nothing else, be aware of who is here today and realize that you can talk to one another, communicate with one another, and rely on one another. Do you want the die? Do you want it?
I don't mind either way.
All right.
Everyone can hear me, hopefully online too. I'm Steph. I'm with the Commonwealth Scientific and Industrial Research Organization, or CSIRO as we call ourselves in Australia. We operate the RV Investigator, down one voyage down to the ice edge every year, and then about 50% operating in Southern Ocean waters throughout the year. And we're heading into a midlife refit next year because we're still operating with most of the systems we've had for the last 10 years, and they're getting pretty dated at the moment. So we're redoing everything at the moment, which is a bit of a big undertaking for the next year.
Yeah, fantastic. Thank you very much. Any last thoughts from the floor? None? Okay. So what I'm hearing from the floor is that we do have a diversity of programs. We do have a diversity of ships at various stages of progression or refit, but there is this common interest in data and how to handle the data, how to process the data, how to deliver the data. Is that a fair thing to say? So there are different approaches, but I would say that there is a phase of acquisition where the sensors are collecting the information. There is a phase of accumulation aboard the ship where it's written to disk in some form or another. From that accumulation, it is then organized in some fashion on disk. And then it needs to be delivered to data centers. There is likely to be a quality check inserted in there in the middle. And then once the quality check is completed, then there is a broader delivery of, there may be processing into products, but at the very least there's delivery and then further processing. Does that sound fair? Are there other pieces that I've missed? Yes, Ria.
Always on my legacy bandwagon. And I can just tell you that, just Anne mentioned that Agulhas was built 11 years now ago. And luckily from Roma in Finland, where it was built, the guy that was totally involved in it kept all the data, or not the data specifically to the ship itself, but to the people working on it. And you guys is now starting building new ships. Just keep in mind that you've got to keep that data also preserved to a certain extent. If we looking at the heroic age of Antarctica, we've got all these people working at it. These days, it's just it's just people doing it, but actually it's people that's making it happen.
Yeah, and the other thing that I would add, at least from the Australian experience, is that, and people can correct me if they've had other experiences, but it's good to think about data from the outset. We talked with the people during construction and resourcing. That's how we ended up getting the data officers aboard the ship. So the earlier that you can think about planning, the better it will be. You don't want to sort of get to, oh, commissioning's done and we're collecting information. Right, we're collecting data. How is that actually going to end up happening? And I'm seeing some smiles from both Investigator and also the Schmidt Ocean Institute. So yes, do try and get involved early in terms of delivering information. Again, I can speak to the Australian experience, and then people can feel free to chime in. We do use two bits of software, Open RVDAS and Open VDM. The developers of which we're fortunate enough we're going to be having with us later today. But what Open RVDAS does is it's an open source software package that collects all of those different data streams and does that organization step that I was talking about. Open VDM, it takes that information and then helps to organize it in terms of storage. That was the other piece that I was talking about. So those are two pieces of software kit. Can I hear from the floor, are other people using Open RVDAS and Open VDM? Do you want to speak to your experiences or how you're using it? Do you want to speak to it, Stephanie?
Yeah, sure. Well, we've just started using OpenRVDAS, so we're still in a transition period between system TextS and OpenRVDAS. But we've got it pretty much fully implemented and we're running it alongside. We haven't started using OpenVDM yet.
Mhm.
We're still trying to sort out if we want to take that route or not.
Yep.
Different. So I'd be keen to hear that.
Yeah, and that'll be part of the discussion. So rather than stealing Web Pinner's thunder, I would encourage you to wait for that particular session. Do you want to speak to Schmitz?
Sure. So we, on our previous ship, which was now we call it Classic, we used OpenVDM and NOAA's SCS framework. So we've just switched to RVDAS on this ship as well. And it's been working quite nicely, but we can get into the details of that later. And we've added some of our own features to it. But one thing I'd like to add to what you were mentioning earlier is not just the collection and collation and getting it off the ship, but the need for the real-time access on the ship for science to be done. And that's something that we've been able to really implement more with RVDAS as well and have more feedback on the ship.
Yeah, and that's a good point. And that again speaks to why we wanted to have the data officers on board, because it's not this thing that things magically happen and you do have to work with things in real time. We do have to deliver things in real time. We have engagements with our Bureau of Meteorology. Our Bureau of Meteorology are very interested in near real-time information coming off of the ship. So obviously our bandwidth is not unlimited. And I think that this may be a case with a lot of people that bandwidth is expensive, especially, and it's not always reliable when you're in the Antarctic. So you need to think about things. Alex, do you want to speak to yours?
Yeah, well, Brendan's got his hand up again.
Yeah, Brendan, please go ahead.
Oh yeah, I just wanted to comment that Scripps Institution of Oceanography, who is my direct employer, has moved all their vessels over to OpenRVDAS and OpenVDM, and we did just deploy it onto the Coast Guard cutter Healy as well. And it's been working well. There's further development and work to do, but so far we've been pleased with it over some of the prior solutions that had been in place. So thank you, Webb and Pablo.
Okay. Thank you. Alex, your experience with Sir David Attenborough?
Yes. Confusingly, we also use a system called RVDAS, but it's not got the open bit. It's co-development. So we co-develop it with colleagues from the National Oceanography Centre in Southampton, who were using TextS for a long time as their underway data logging system, but decided a number of years ago to trial an in-house development. They claim that they call it RVDAS without knowing about Open RVDAS, but then everyone calls it Research Vessel Data Acquisition System. It's just the so we need a new name. One of us needs a new name.
Yeah.
So we did an exercise at the start and looked around the kind of all of the open source and closed source data logging systems. This is for underway data logging. And at that point, I did get a submission from Open RVDAS, and at that point, it wasn't quite the state it is now. And so when it went into the mix, we decided at that point, this was 2020, maybe 2019, to continue using NOAA's SCS, which the majority of the US academic fleet still use, because that is what we had used previously on the James Clark Ross. So it was familiar to us. And then we, at the same time, for I guess political reasons, decided to use to trial the NOC software as they were developing it, because it is used on the other UK deep water research vessels. So quite a lot of the people who come on to the David Attenborough also do oceanography and other marine science on the other two vessels. So for UK researchers, was an advantage in some kind of consistency across the UK research fleet. As we used it, we realized that it gave us many advantages of the SCS, one of which was that we could actually continue to develop it ourselves. SCS is as it is, but we cannot. It is closed. It is closed to us. You know, we were using it, and we get great support from NOAA, but we couldn't just go in and change the code underneath it. And so that was one of the advantages of having something we could meddle with. Is that you could obviously make it bespoke. So in the end, as time went on, as we got into the commissioning phase, RVDAS, or the NOC software, became our primary data logging software. And we still run the SCS, but in a secondary fashion as a backup. If RVDAS completely goes down, the SCS is just working in the background with a complete duplicate replication of almost all of the sensor information. And that doesn't quite get us to today. So to start with, the NOC team have got a set of developers, 4 or 5 developers. We had just me to start with, but since then we've hired a developer, Mike, over there, and others of us have got involved. Our IT guys who were very heavily involved on the James Clark Ross in the development have also got on board in working with RVDAS. So it is now a true co-development. We are, in fact, I guess for the last year, we've probably done more development work on some elements of it. At the base of it, it is very similar to the same kind of functions that occur in all of the data logging systems that we use. They are there within RVDAS, closed RVDAS, I guess let's call it. And that gets us to the present day, where we've done similar to those that have also got new vessels, is that we've brought sensors online, and we have a pipeline through from sensor through to data logger, through to disk, through to data visualization, data access at the end. There are a number of components that are common to all of us that we've not quite got to yet. Ship-to-shore transfer is not quite there yet, although I can talk to that later as to things that are increasing there. Sensor metadata is not where I want it. The integration, the creation of well-described output files, or self-describing output files. And there are another things that I've probably forgot about because I haven't got my slides in front of me.
No, that's okay. Again, this is intended to be a discussion, but that's, again, there is the technology. It's one thing that I've run into as a pattern is that there's a diversity of requirements. It's certainly not, I think it would be very difficult to develop a complete turnkey solution. And so I think that there is a need to place an emphasis on open systems that can be expanded, extended, and worked on. So I'm not talking about a particular bit of kit, but I think that at least for the time being, that an open source framework would work well. Also, yeah, I think that it's that open framework that I was mainly thinking about. And then yes, ship to shore is a common pattern that we go through as well. So there can also be different types of logging as well. There's logging from sensors, but there's also event logging. So again, from the Australian experience, we actually have been developing event logger software. So I don't have any slides on that at the moment, but I can just tell you that we have been working on it. Tess, are you online? Would you be able to speak a little bit about the event logging software? Are you there?
Yeah.
So the event logging software is something that I actually think originally the crux of it came from an honors student somewhere. But anyway, we've then developed on for the e-log and have it on the ship at the moment. Just let me know if you can hear me all right, by the way.
Yeah, we can hear you just fine.
Okay, perfect. And I'm actually just trying to log on because I'm remoting into the ship at the moment to see, so I could give a screenshot of the e-log, but anyway. So it's somewhat simplistic in a way, just based with on a Postgres database. And then we just have a web app on top of it. And then for each voyage, we'll put for instance, on this voyage, since there's no dedicated science, we have forms, quick tab forms at the top for data management, ocean chemistry, ice wave radar, and our MET sensors. So we just try and make it pretty easy like that. And then just have like the event type, the tags, both the time it was entered and then the capacity to go and change it, for instance, if like for our XBTs, when we shoot them off the back of the ship, there is a bit of a lag in the software in the time it actually gets recorded. So it's quite handy having the ability to put like the time entered, but then the actual change it to the time of the actual recorded event starting. That makes sense. And yeah, and then just a section for comments as well, and then author and everything like that. And then we release it at the end of the voyage with our whole voyage data, which we loosely base on the R2R, the rolling deck to repository kind of structure. And then there's just an e-log top level directory there.
Okay, thank you very much. Do other people work with logging software, logging events on ship? I'll start with Nils.
Yeah, we developed our own software within Eurofleet's project, so it's called EARS.
Yep.
So it's
EARS?
Yeah.
Yep.
So it links. You can select different tool categories, so it's linked to ontologies. And if an event is entered, then it's also linked with the sensor data at that moment. So not only location, but also meteorological data and so on. It doesn't always work that perfectly, so there are still some bugs. It's also like some old software which has been rewritten. So there are some mistakes that are getting into the code already from years. And if it works, it's very useful for scientists that they have all the data at the same place for their events. They can also change the time for the event, and then the data is re-extracted from the database so that the data is correct.
Yeah, thank you. So that's a good, so again, that's a common pattern that, you know, there needs to be the ability to go in and modify the time and change it. So that's something to think about. Schmidt Ocean Institute?
Yeah, so we are using another open source package developed by WebPinner, CLog, but we've worked this year to heavily integrate it with RVDAS and other systems. That sounds very similar to what Tess was talking about, but it will pull, now you can set it up to pull specific data from the database for any specific event. And we have different versions of CLog for our remote operated vehicle versus the ship. And then we're working on automated reporting engines at the end of the cruise that can collate all the information into a PDF that's more usable for scientists.
Yeah. So being able to take the logging information and to pump it into some sort of easy human readable report, that's sort of a good function that people would like to have. Stephanie, do you have anything that you want to add about logging?
Yeah, we've developed our own as well.
Yeah, and let me say there's no wrong answer here. You know, nobody should say, oh, we did our own. But it's just like we said, oh, you know, a whole bunch of people are using OpenRVDAS, but some people aren't. It's useful to say, oh, well, we have a whole bunch of different logging approaches, and there may be good reasons for it, but this is exactly what I want to have happen, is just to get it all out on the same page so that we can be aware of it. So anyway, sorry, go ahead.
And I think, yeah, the features would be pretty similar to what everyone else is talking about, you know, ability to change the time of deployment if it wasn't, if you entered it at a different time, then it was deployed, and associating tags similar to the one so that you can link things together with the concept of tagging. Yeah, and just has a web interface, and currently we're developing an onshore mirror of that as well, because we have a lot of onshore only scientists, BOM and the Bureau of Meteorology and
The Bureau.
and then other scientists within the organization who don't get to go on the ship, but they like to be able to access the events and also contribute to the events, because sometimes they do remote maintenance and things like that on some of the sensors and equipment on board. So
Okay.
where we're at with that.
No, that's fine. Does anybody else have anything that they'd like to add, or that they think that they would be able to add on in terms of logging? Taco?
Yeah, until earlier this year, we used the Casino Texas combination that Ifremer has developed. And during summer, we replaced it by a system based on the same, at least the same data model of Casino in Texas, and we call that ships data. And that's now operational on our research vessel, and will be operating the system on our new research vessel.
Okay.
Vessels.
Yeah.
Another question.
Sure.
Is it useful to make a kind of formal inventory of all these different approaches? Just have a list of all these.
And I think this is.
We can contribute with additional information. So an online system where we can additionally.
Well, at the very least, this is my intent in having Dave here, is to take note of everything that people are talking about. And we are going to get it into printed form to share. And then it is my full expectation that people who didn't participate but looked at the recorded sessions will be able to say, oh, there's also this thing here. There's also this thing here. But this printed document is going to be the nucleus of that discussion. That's my intent anyways. I'll let people continue, but I also want to remind people, this is the introductory landscape session. We do have a dedicated time to be talking about logging, but I do think that it's important to just start with getting everything out on the table. You look like you are going to contribute. Yes.
I'm Johan Ladroit from Kongsberg Discovery.
Oh, Kongsberg, yes.
I used to work for NIWA for 10 years, so what I was going to say is that in some situations when I was there, quite often it was we had the logging system and a data acquisition system that was a mix of homemade software and Texas, and it was quite often relying on very few people. So when those people leave, it makes it quite tricky. We looked at OpenRVDAS as well at the time, which we implemented for our small vessels, and that was very successful. But then again, it was difficult to maintain without the people behind it. So when I started with Kongsberg, we looked at making supported software to look at that, and we're now developing something called Blue Insight Geomatics, which is intending to look at that, especially for people who don't have the capabilities to write their own code. Otherwise, I fully understand, and the open version is better, because that's what I would have wanted when I was.
Yeah. And this is another common theme, is that while open is good and extensible, it does require developer support, and not everybody has developers in their back pocket, but there is a common need. So I think that being able to coordinate, or even if not coordinate, at least align the efforts of developers in a cohesive way would be useful to do, so that, rather than everybody working on the same problem, that they can work on different parts of the same problem. So the fact that we do need developers is something to think about. Anybody else want to add anything on the logging front?
Yeah, I'll say a little bit about
event
logging. We also have an event log. It was developed a long time ago, probably 2010, maybe before then, on the James Clark Ross. That was developed by one of our members of IT here, and it hasn't actually changed very much since. And there are many things we would like to, lots of people have mentioned the kinds of functionality that it has in there. So, it has a timestamp that you can change. It draws in data from the underway data streams. It is incredibly flexible and relatively basic. And because of that, people have used it. And that is actually its number one attribute at the moment, is that people use it extensively for equipment, event logging. The bridge use it extensively, so we have effectively double recording because scientists can get very excited and miss things, whereas the bridge is very dispassionate and tends to record things as they occur. So that provides some difficulty because sometimes you get conflicting accounts, but at least you don't get missed events. So lots of the improvements that we want to make are around the data management, standardization, the templating, so people don't keep creating different C2D event logs every single cruise. However, we have to be very mindful that we don't kill what is a very successful, well-used system by making it standardized, but then finding out that no one puts it in. People just go straight back to their bespoke logs that they were always using, on Excel or paper or whatever. So that's the tension that we have when we look to revise it. We did revise the event log, or the IT staff member revised it for the new vessel because we had a different data logging system. There had to be some development work that targeted new underway data streams. But other than that, the look and feel of it is exactly the same.
Fantastic.
But that is a big. And the other thing I wanted to mention is over the last couple of years, with colleagues from around the world, including Thomas, we've mentioned EARS already, which is underneath is also an event ontology. We did work to create some vocabularies out of that that basically took EARS and R2R, some of the terms around those, and tried to bring them together and put shared descriptions. And there are two vocabularies, event processes and event actions, that are now on the NERC vocabulary server, which I know that some people around this room use NERC vocabs. So that is something that's occurred. Whether they are the right terms or whether they can actually be used in reality to tag, to put into event logging systems, I don't know, but it's a start.
Yeah, well, I'll dive down that path, but just a couple of observations. I often think that there's a triangle of power, flexibility, and ease of use, and you can get two of those, but never the three. So, especially if somebody's using something to that extent, you want to try and preserve that. And often the mark of something being successful is if they're using it for a purpose for which it was never intended. So if you can preserve that, then that's good.
I should add that at the moment, the data managers on board and after the fact are the people that create that standardization behind the scenes. So the flexibility occurs at the user interface, but then it's us that take the hit.
Yes.
Of basically funneling it into an event model that is standardized back in Cambridge.
And you've hit on a real major point here, that tension between flexibility and standardization. Standardization draws it in, flexibility branches it out, and that somebody needs to make that decision. And so, de facto, it probably is with those data managers. But yeah, it needs to be considered as part of a larger whole. That other path that I was going to dive into relates to vocabularies, because this gets into the standardization aspect of what a lot of people work with. So I'll offer up at this point that we made the conscious decision within the Australian Antarctic Division, at least in the marine space, to try and work with the NERC vocabulary server terms. There was a lot of tension. There were a lot of people who wanted to have the climate and forecasting. I do know that climate and forecasting can be considered as a subset of NERC vocabulary server, but that's what we ended up going with in terms of the terms that we use. Does anybody else have things that they'd like to talk about on the vocabulary front, or are people converging on using the NERC vocabulary services. Do people know about it? Back at the back of the room.
Hi, I'm Rebecca Ingram. I work with Shannon on CCADI.
Yep.
And I was the person making the decisions.
Yeah.
On the data side. So one of the things that we've been doing in terms of interoperability is trying to consider all of the different vocabularies. And that actually makes me feel much better that there was that tension between CF and NERC vocabulary. We also brought in BODC, and on kind of an earlier topic, one of the things that we also had to consider was the data that was coming in from Amundsen. So I think that for me, it's interesting for me to come at it from this perspective and to hear from all of you, because it helps me to understand kind of the variety of the data. One of the things that, and I'm glad that you kind of brought up vocabularies, because I think, and I know that there are data managers that are on the vessels themselves, but I do think that it's important to be thinking of the metadata and the standards and the vocabulary along with the very beginning of the planning, because it will make it easier when you're going to reshare the data, or where, so in the case of CCADI, where we try to make everything reusable, shareable, findable, accessible. So that the more that we know about what is being used, the easier it is for us to account for it when we're making these large databases for shareability.
Yeah.
So yeah, it helps to hear from people that are kind of in the beginning stages and carrying out the actual data processing.
Yeah, and welcome. I met some of your other CCADI colleagues previously at the International Data Week, which was before.
We're everywhere.
And but at International Data Week, a big theme, which shouldn't be a surprise to anybody, is data interoperability. And the standards, the vocabularies are your key to interoperability. And I remember having a discussion with Simon Cox of CSIRO a long time ago, and he said he's a veteran of the wars, and he said he learned a long time ago that you don't design according to the standards, you map to the standards, because otherwise you're just making a rod for your own back. The standards are absolutely critically necessary, and you need to have them in place as that layer in between, but you want to be mapping to those standards. So again, this is what we may work with some things internally, but we fundamentally want to be mapping to, in our case, those NERC vocabulary services. Does anybody else want to speak to, and you know, NERC does a solid job, but it doesn't need to be everything to everybody. So does anybody else have vocabularies that they would want to talk about, or that are important to them? Does anybody else use the NERC vocabulary services?
Yes, in Spain.
Yes, so Susanna uses them, and Nils uses them as well, and Taco. So again, there appears to be some degree of community acceptance of the services, and they're certainly well maintained, and they're certainly well accepted as well. So another theme that was brought up as well is that there's increasing use of multi-beam as well to collect seabed information, to collect water quality information. It's a relatively dense data type. It requires processing on board the ship. If it needs to be integrated into larger national collections, it may need to be reprocessed on land. There's water column information as well. So again, priming the discussion from the Australian experience, we're working with our hydrographic office to try and get permanent hydrographic staff aboard our icebreaker so that it can do transit mapping and fill in the gaps. So we do have collaborations with the Seabed 2030 project. I'm not sure if people have heard about that, but also GEBCO mapping. But it's this initiative that, you know, it's not just those dedicated sort of charting surveys, but whatever we can do to fill in the information. And I think, again, speaking off the cuff, I know that the hydrographers that I've worked with have been usually been thinking of things in terms of safety quality information. That's the bar. It has to be, sort of top shelf. Whereas a lot of biologists, a lot of other scientists are willing to accept quite large margins of error if they just have a broader sense of what's down there. And so it's this notion of being able to classify that error and be able to separate information on that basis. But in the Australian context, I was saying to Alice Vermont earlier that we have a program called AusCBED within Australia, and it's designed to be a collaboration between industry, academia, government about developing common interoperable pipelines for collecting, storing, and processing multi-beam information. So again, I'll park that discussion there, but does anybody want to comment on their experiences with multi-beam data, directions with multi-beam data? I'm probably looking at our Kongsberg person. Trends, just general trends in terms of multi-beam on chips?
I guess multi-beam is one of them, but all the EK systems, all the single beams also produce now very large amount of data. And I think they're very important to keep using regardless of the amount of data that they are, because they're providing so much useful information for biological things, oceanographic things. But I agree that it comes at a cost in terms of storage.
It does.
And then the transfer becomes complicated and those sort of things. For the mapping systems, there's been tools that have been made so that we can automatically upload the data to the CBED 2030 repositories, for instance, to find some. So I guess, and we've got those products like Blue Insight, which are trying to be incorporating the data in a way so that they will become easier to handle as well. So we can provide something that will help. But we realize that there is a problem. I mean, not a problem but it's just a
challenge.
Exactly, a challenge that we should be able to help solving.
No, that's fantastic. And the problem, as I'm sure everybody is aware, becomes much more acute in the polar regions because in some of the more traversed regions, you can try and work with crowdsourced bathymetry, but there is much less traffic going down to the ice and through the ice. So we need to make the most of all of the opportunities that we have for multi-beam mapping while we're there. Does anybody else want to sort of comment on their experience working with multi-beam data? Frank?
Yeah, I can. I mean, like maybe two comments. One, it's good to see so many new ships coming online, and it's good that hopefully most of them will have multi-beam going to the polar region so that we can collect more. It's great that the Australians finally have multi-beam. I think there's very few data, and
we know.
There's hopefully coming a lot more now. That would be great. And then for the US, I just mentioned there is a actually well-established pipeline that, well, like the academic fleet at least, then plus Schmidt Ocean and others contribute to an NSF-funded pool called GMRT, Global Multi-Resolution Topography, which then gets funneled into.
And I'll let you continue, but I'll just add that AusCBED is leveraging that same infrastructure. So again, here you're starting to see some convergence on technologies, some pooled use. Go ahead.
No, I mean, that was, just saying, I think that's a good example for a good pipeline, and it goes into CBED 2030 as well. And
Yeah, so as was mentioned, we funnel our systems to GMRT and CBED 2030 as well. We don't have the ability to do much processing on board except for like immediate use, so it's mostly processed off. But one thing that I'm starting to become more concerned about is that we're looking into using more and more AUVs, and so then our amounts of data for mapping will increase substantially, which is great, but how we're going to go about dealing with that, I think is a massive question. So not just the shipboard systems, which we have many EK systems on board, but adding this huge amount of fine scale mapping systems as well.
Yep. No, that's absolutely right. Stephanie, you want to comment on multi-beam? It's fair to say no.
Probably not. It's not my area of expertise because we have another group that's primarily focused on that. But
Mhm.
yeah, I guess we do process it on board minimally because we have always a dedicated kind of a hydrographer, but an in-house hydrographer
Yep.
on board doing that, which is great because we get the real-time processing and kind
Yep.
of control, and then they do the post-processing and feed into us the data at the end.
And this is something that we ran into even on Noyena's first voyage. We did some initial passovers of the Vanderford Glacier area and just got a view, and that generated a lot of excitement. And just to reflect, this is a consistent pattern that you do need to have somebody on board for that interactive experience so that you can respond, go into particular areas, go into particular detail. But I am also seeing this general agreement that people say, yes, that was aboard the ship. We're now going to take it back, do a much, like, even if it needs to be redone from scratch, we'll redo it from scratch so that it's to a known quality that integrates as part of a larger collection. So I remember having this discussion with people saying, oh, aren't you wasting your time by reprocessing it? And the answer for us was, no, that's actually not a waste of time. And in fact, it's not even that much effort, because if you can put it into a more automated pipeline on the other side, then you're not asking a human to dot zap everything again. Yes, Taco.
Yes, I'd like to mention here in this phase the European EMODnet bathymetry project, which uses all these multi-beam data to produce a high-resolution bathymetry of the European waters, that is everything east from 20° west.
Yep. Okay. The other thing that I've reminded myself as well is we've been talking about, or at least I've been alluding to icebreakers and large ships and things like this, but there are also a number of small vessels that are able to collect information, not just multi-beam information, but all variety of information, and they should be part of this discussion as well. But at the same time, we're still talking about vocabularies, we're still talking about collection, we're still talking about organization, we're still talking about delivery through data systems. And at the end, part of the reason why I'm interested in this and why we wanted to talk about this as SCADM and why we put this together is that we represent, or many of us represent, different national Antarctic data centers. And we, at the end of all of this, it's good to have interoperability at the processing stage, but at the very end, we do want to be able to say the UK collection, we can have that be interoperable with the Australian collection, and we can have that be interoperable with the French collection and all around. So part of what I would like to get out of all of this, besides having that common operating picture, would also be to have a roadmap towards interoperability. So how can we agree on, again, we don't need to design to consistent structures, but we should be able to map to consistent formats. We should be able to map to consistent vocabularies. We should be able to map to a consistent arrangement so that when BAS is looking to pull things from the Australian Antarctic Division, they know what to expect. When Spain is looking to pull something from Italy or from the Netherlands, they would know what to expect. And then we're not constantly having to build new transformation tools over and over and over again. And so there are common patterns such as rolling deck to repository, but at this point, I'll also say, I'll now turn to the audience. We've been talking about these common patterns. What are some of the pain points? What are some of the challenges that people feel that they're running into? Some of the things that make you say, oh, if only I could, or if only somebody would. I'm absolutely certain that there must be some challenges out there somewhere. Anyone? Alex, you're looking like you have challenges.
Well, Tess had put a note ERDAP, so that was getting onto interoperable data access, but just to put that out there, just as a comments coming in. But
okay, yep.
Points. So one of the observations, again, it's going back to one of my slides. I've got a number of observations that we've seen over the last 2 and a bit years, and there is something about opportunistic data collection versus the reality, the constraints that you get on board. So this isn't just around data management. This is about the operation of a ship, but it comes home to me because when I was developing the data systems, I want those data systems to be as full as possible. I want them to be acquiring all the sensors all the time.
Everything all the time.
That cannot happen, and I can't control many of the things, the reasons why that can't happen. I can try and facilitate it to be better. I can make the data systems as flexible, as easy to use as possible. So that, but ultimately, we found with the new vessel is that we all went in with the idea that everything would be on all the time, but in reality, that hasn't happened through often people resource. You know, you can have the sensor sending out data all the time, but if you haven't got engineers who can make sure, or lab managers who can make sure that the instrument itself is well maintained, you'll just get degraded data. The data will just get worse and worse over time. You know, I haven't got the domain expertise to fix everything. Even if I was on board, I couldn't do that. So inevitably, you're seeing systems not on for periods of time. Then there are political reasons why things are not on. You know, if it was up to me, I'd acquire data all the time, everywhere.
Correct.
But countries, EEZs, prohibit that, and once it prohibits it, you start getting into a cycle where things don't get turned on because you know you're going in somewhere that you haven't got diplomatic clearance, and then they just don't get turned on again. And you miss a whole season because of inaction.
Correct.
Those kind of things. And then we talk about multi-beam. We historically we've put a lot of effort into opportunistic multi-beam collection, especially through logistics legs, where we have been, the data manager, been the driving force in getting the ship to divert slightly off course to get new data on passage lines. And that took a lot of effort. And it was difficult to do. We tended to rely on onboard IT who were there anyway, but there wasn't other support members there. They would do as best as they can, and then we deal with the data when it got back to processing, but making it available to JEBCO and others. Since the advent of the SDA, we've got into marine mammal observing sessions, which adds another constraint, which is almost a barrier too far for the resource that's on board the ship in those logistics sessions. So there's another thing that's come in, and the amount of opportunistic multi-beam that we now get, despite the fact that we've got more multi-beam, we've got 2 multi-beams now, and a whole array of other acoustic systems. Our actual use, as we've seen over the last couple of seasons, has actually reduced significantly, because that barrier is just enough to say, oh, it isn't just turn it on. It's actually, you've got to go and you've got to become a marine mammal observer. You've got to spend an hour looking out, and if it's at night, you're not doing it, and all the things that comes with. And so I guess there is an array of things, of pinch points that go away from the naive everything all the time to practical reality.
Yep. No, these are gotchas, and you didn't look behind you, but the representative from CCADI was nodding at several points in your discussion. So you're clearly not alone. Are there other things that people would like to add? I'm absolutely certain there, but this is the time. You know, this is the opportunity to say, look, these are the things that I've run into. I wish somebody would do something about it. Yep.
I'll throw one out. I think I've heard quite a lot of, I agree with everything, especially permitting and sequestering of data as well. But another one, I think we're gonna have a session on it, is with sensor metadata and calibration information. So being able to have a simpler, more automated way to have that information always, with the data, as marine technicians are changing things out very quickly in the middle of the night. So that kind of automation somehow, I think we are definitely working on it, but still lacking.
And how do you sort of maintain that information so that you can see and be able to go back and reconstruct the changes that would happen? What happened there? Sort of the values changed, and wanting to find out about it. Taco, anything from your perspective? No? What about you, Nils? Is this sort of answering the sorts of questions that you had?
Yeah.
Yeah, fair enough. I'm not looking to put anybody on the spot.
Brendan's got a few points.
Yeah, Brendan, please come on in.
Hello, can you hear me?
Yes, we can hear you just fine. Thank you.
All right, yeah. One thing I do struggle with is providing technical resources, especially the right people at the right time and enough of them to monitor these highly sensitive but critical data sets such as multibeam or EK80. It's a constant struggle, and sometimes we have to make sacrifices on what data we can collect and who we send. So that's an overarching issue with the research fleet in general, is these individuals that sail on the ship for months at a time sometimes, that have the right skills, that they may not have a PhD, but a lot of them went to grad school and chose other paths, and they are not common. So trying to find the right people to sail on these ships to help the academic community and to compensate them appropriately, especially if they have cyber infrastructure skills. How do you compete with a shoreside job that might make $150,000, $200,000 a year, and then you want to send them to sea to do the same type of job? So that's a constant struggle we have, is talent retention and also maximizing efficiently underway data collection. So it'll be interesting to see how some of the developments with AI can contribute to this, but you can't get away from someone sitting in front of the screen monitoring the underway systems. And I know Kongsberg has done some interesting developments with SysRemote and some of these remote monitoring softwares. But if you're in the high latitudes, as most of us are involved in some way, then the data may not be able to be transmitted in real time, and bandwidth is a major issue. So human resources are one of the biggest factors, I think, in proper data collection and essentially. Thank you.
No, you're spot on, and don't want to air too much dirty laundry, but yeah, it was quite a challenge in the Australian Antarctic Division to persuade some of the powers that be that it was necessary to have the data officers on board. But paradoxically, it was actually a relatively easy sell to the high level ministers and politicians because they recognized the value of having a lot of this mapping information come out and a lot of this. So I think I don't have a direct solution for everybody to take and to use, but I think that what we can say is, look, there are examples where we have this dedicated staff and there are clear demonstrations of value and output. So I can't speak to any of the other programs, but if you needed to contact us for an example of what we've done and what we've got out of it, then that's something that we could potentially share.
David had a point online about this is going back to sensor metadata.
Yep.
Coriolis folks at Oregon State have been focusing heavily on automating uptake and storage.
Yep.
And Tess has got a hand raised.
Yep, Tess, go ahead. You're going to defend the data officers?
No, not at all. Of course I am. Sorry, me. But I see there's other sessions, and well, no, Jonathan and I forever have questions. So I'll save those for those. But I guess the question for the room would be on kind of information management, because on RSV Noyina, we have what we fondly call the Noyinapedia, and it's a wiki, which I know a lot of ships have. But how to sync the shipside wiki with the shoreside wiki is something that we've been looking at and looking into for a while. So I don't know if anyone has had similar experiences with trying to sync those kind of information services up.
And for your awareness, we shamelessly poached that from Schmidt Ocean Institute in terms of setting up that wiki. But We've had a lot of good experiences in terms of it being a general resource for people to go to about instrumentation, procedures, things like that. So just keep it in mind as something that you can have aboard, that you can potentially have aboard your vessels.
I fully agree with that. We struggle with that hugely about information sources. And the reason it's so difficult is that you see the vessel as an entirety, or I do, because that's my job to do that, you know, that particular vessel or a set of vessels. But you are in other realms, you are just part of some other larger thing. So lots of our information is held through our engineering teams. The ship is just one platform that they support. So they have their Infopedia bit, with the ship just being a small part of it.
Mm-hmm.
You know, they can't have their universe be the ship because it includes all the other stations, everything else that they support. Our inventory management system the ship uses for ship side stuff, which ends up bleeding into science side. Their kind of planned maintenance type system that isn't just for the ship either. So that also bleeds out into other things, including like the estates here in Cambridge. So you're always fighting to get back to your vessel as the universe part. And the only way of doing that is quite a lot of effort because you're into symbolically linking things and making sure that you're only picking up the things that are relevant, that you're not taking the 10 versions that are out of date but are still on someone else's information side.
Yep, and this is an interesting segue because I'll talk about a pain point for the Australian Antarctic Division, which has been similarly, we have our technical and engineering team, which will store their standard operating procedures, which they want to have in our official repository. And but at the same time, they want to be able to make changes when they're aboard ship, but they want it to be the established point of truth. And so what ends up happening is we have our official document repository system, but it's operating on this assumption that you're online all the time, infinite bandwidth, and it just doesn't work that way. Now, fortunately, we actually had a discussion with the commercial vendor about our unique issue, and they've decided to take it up. I think it's not just because of us, but because they work with mining companies and other people who are in the field. So they appreciate the need for being able to sync and have a narrow bandwidth. But this is just to speak to, yes, it is a real issue of how do you work with these corporate systems, especially as there's this increasing push towards cloud and always on. How do you integrate with those corporate systems aboard a vessel which may or may not be connected at any particular time? And in the times that they are connected, they have a very thin data pipeline. While it's true that you're having things like Starlink come on, even then your bandwidth is going to be limited. So how do you work with the technologies? How do you work with the companies in a world that assumes we have greater connectivity and we're going in the other direction, saying that we have much less connectivity? Yep. Question?
No, I was just, I totally agree with that. It's a big challenge that we've had as well with, we seem to be using a few different systems at the moment. We'd like to get everyone, together to using, to standardizing on something on board instead of, some people use Wiki or another system that's commercial, or Confluence as well, or they're using OneDrive to sync documents and things like that. So we're really trying to get that into a single thing that we can all use.
Yeah, and you can have some unintended consequences as well, because if something does end up using large amounts of bandwidth, it's not just that system which tends to be affected, but it's everybody's experience. So, everything from the Polar Med to systems. So how do you manage? I know that starts to bleed into the IT aspect of things and quality of service and sequencing. Oh, did we lose our connection?
No, Dave, it says you start sharing your screen.
Sorry, I'm just reminding you that it's break time.
Oh, it's 20. Well, I was just
I have a nice slide for it, but it's not coming up.
I was just too excited. Anyways, let's,
It turned up, it knows the difference.
we've been terminated. So I think that we come back at 11 o'clock, I believe. Is that when we're back?
10:40.
10:40. Okay, well, we'll give it, please come back at 10:40, but we'll.
It's all right for those online. We're gonna, well, for those here as well, we'll pause recording now.
Yep.
And we'll turn off the mics in the room, so
Yep.
so you can feel free to talk about the people online.
Yeah, please, absolutely. Absolutely. So please, let's reconnect.